Whoa, want to see that again? You're going to have to endure a balancing lesson first. What you just saw was the combustion of acetylene gas, C2H2. A combustion reaction, by definition, is when something is burned in the presence of oxygen. Because we're working with a hydrocarbon, it's all going to be converted into CO2 and H2O. So we're working with C2H2. We want to start by balancing our carbon and our hydrogen atoms first. This is always the case with combustion atoms. Because oxygen is in 3, maybe 4 of your species, you always want to save it for last because things just get too complicated. So let's check out our hydrogen and carbon atoms first. We have 2 atoms of hydrogen on both our reactants and product side, so that's already balanced. Now let's check out our carbon. We have 2 atoms of carbon in our first reactant. We need to put a coefficient of 2 out in front of CO2. Now I'm going to count up my oxygen atoms on my product side, the right side. I have 5 atoms of oxygen, and oxygen is a diatomic molecule. So I have 2 atoms of oxygen on my reactant side. I'm going to put 5 halves there temporarily. Yes, I cannot have half of a molecule, but this is just going to help me keep track of things as I then go through and multiply everything by 2 to get rid of that fraction. So I put a coefficient of 2 out in front of my first reactant, 5 in front of O2, CO2 has a 4, and H2O is also going to have a 4. Let's just double check to make sure everything is balanced properly. Everything's matching up on both sides of my arrow, so I know I have done this correctly. Want to see that reaction again? Here is the combustion of acetylene.